Hello world, I'm Luca Bassi, I'm a computer science student at University of Bologna and I'm participating in a GAR scholarship at INFN CNAF. This is the INFN CNAF Tier 1 data center in Bologna, Italy. It's mainly used for storing and elaborating data for high-energy physics experiments. It is also connected to the CERN Tier 0 data center with a whopping 1.6 terabit per second connection with less than 10 milliseconds of latency. With this speed, you obviously want the best possible performance, but let's start from something simpler. Normally, when you start to deploy a server, you use a topology like that. A server connected to the internet via router. But you want redundancy and scaling up, so you increase the number of servers. Now you need to distribute the internet traffic among them, so you need to buy load balancer, place them between the router and the servers. As a consequence, you have now added an extra layer between your server and your user, and also probably spent 10 or hundreds of thousands of euros. Network equipment can be very expensive. This load balancer, if not managed correctly, can become a bottleneck, thus slow down the connection, or worse, a single point of failure if, for example, there is an error in the configuration of there is only one load balancer and it breaks down. Wouldn't it be nice if you can avoid this and let directly the final server to forward the traffic to the correct one? In this way, it's possible to avoid the cost of buying new load balancer and the burden to manage more network equipment in your data center. XDP can provide this. Express Data Path XDP permits to process bare metal packets at the lowest point in the software stack, making it ideal for speed. Every time a packet arrives, the XDP programs are executed before the kernel network stack. These programs can inspect the network packet and also modify them, and based on this data decide what to do with the packet. At the end, the XDP program must tell the kernel what to do with the packet, accept it as if the XDP programs were not there, drop it like the packet had never arrived, or redirect it, for example, to another server. There are three main use cases of XDP. Packet filtering, for example firewalls, packet redirection, such as load balancer, and monitoring. Currently, this technology is already used for load balancing by big corporations such as Meta and Cloudflare. At INFN CNAF, Italian WCG Tier 1 data center connected to the GAR network, we are experimenting with XDP. In fact, we have developed a proof of concept load balancer using XDP. To wrap things up, XDP is an interesting technology that NRIs can use to deploy high-performance firewalls and load balancer and to monitor network traffic. XDP permits to develop fast, programmable network data path in the Linux kernel without the burden of patching the kernel or maintaining modules. In this way, it's possible to avoid the need of buying new hardware and managing it. Thank you for your attention, and if you want to learn more, you can contact me by email.